In our second example of solving a system of equations in two variables, we're going to use the elimination method. Again, the thought process is for both of the methods, substitution and elimination, you go from two variables down to one variable, solve, and then work your way back up. Now, in the method of elimination, what you do is you try to eliminate one of the variables by multiplying one or both equations by a non-zero number, such that when you add the equations, you cancel out one of the variables. Now notice, let's compare the x's. We have 3 and 4, and the y's we have negative 5 and 2. It's not really going to matter which variable we eliminate. Both of these, we're going to have some work to do. We're going to have to multiply both equations by a number to get rid of one of the variables. Since the y's have one negative and one positive, let's work with them. We need possibly what would work best is the least common multiple of 5 and 2, which is 10. So notice we can take the first equation and we just need to multiply it by a positive 2. We'll take the second equation and we'll need to multiply that by a positive 5. Doing so results in the new equations. For the first equation, multiplying by 2, we get 6x minus 10y equals 16. For the second equation, multiplying by 5, we get 20x plus 10y equals a really big number, which happens to be 140. Okay, it's not that big, but you get the idea. Now, the reason we did that was notice that we have a negative 10y and a positive 10y. So now if we add these equations, the y terms would cancel. The elimination method is also called the addition method for that reason. You want to add your equations. Adding them, we get 26x. The y's cancel, equal 156. Now note we're already down to one variable. 26x equals 156. Since we're multiplying by 26, to undo the multiplication, we're going to divide both sides by 26. Doing so, we get x to be 6. Now since we have x solved for, we can put that 6 back into either of the original equations. It does not matter which one. You might as well pick your favorite. We'll pick the first one just because. So instead of that x, we'll have a 6. 3 times 6 minus 5y equals 8. Let's solve for y. 3 times 6 is 18. Everything else just copies. Subtract the 18 from both sides. We'll get negative 5y equals negative 10. And then dividing both sides by negative 5, notice we get y to be 2. That gives us the ordered pair 6, 2. Just as before, let's check this. We'll put in 6 in for x and 2 in for y. Always go back to the original when you check, just in case you made a mistake along the way. This gives us 18 minus 10. That indeed is 8. We'll do the same thing for this other equation. 4 times 6 plus 2 times 2. This is 24 plus 4 more is also 28. So this works out. So the lines 3x minus 5y equals 8 and 4x plus 2y equals 28 intersect at the point 6, 2.